We're good. All right. So, precision. When I'm doing my precision problems for part number 2, I want to make sure that I am showing all of my work and labeling whatever I can and then getting the correct answer. All right? So the second section on this is just getting the right answer and showing any and all work I can think of. All right? So as I'm evaluating each numerical expression, I need to find the correct answer. They're getting me to one answer. I have division, subtraction, multiplication. Division and multiplication are tied. I solve those from going left to right. I do one step at a time, which is a pain, but I'm only asking you to do one step at a time for approximately 6 problems. Then I have subtraction, multiplication. Multiplication is cooler, so I do 8 minus 8. 8 minus 8 is going to give me my answer of 0, which is what my first answer should be. Second one, parentheses is the winner. So I do the parentheses before exponents and before addition. Then I have exponents. 3 to the third power, remember, is 3 times 3, which is 9. 9 times 3, which is 27. And so, like, if I needed to figure anything out, although I probably didn't need to do that one, I want to even write that down for a couple of reasons. First of all, to double check I've got the right answer. And second of all, to show every single thing I've done. The last step is I'm adding. If I needed to show the adding, I would show the adding. And then I should get 42 unless I've made a mistake. Then, third, as we go, we have addition, division, and exponents. First step is exponents. So I leave everything the same in the same order, and I just do the one step. 3 squared is 9. Next I have addition and division. Division wins. So I do 12 plus 5, and then I have one step left, and I should have 17 as my answer. Then the next one, so these are algebraic expressions, and they want you to evaluate the algebraic expressions. And so this is actually the same. I noticed when I was reading this that they didn't say, hey, put this in words. So that's kind of nice, because some students were getting confused by that. So for this one, that direction wasn't given, but I still want to look for it for the summative assessment. All right, and so when I do this problem, my first step would be to rewrite it by putting the number in for the variable, by substituting 6 for y. Now I follow my order of operations. I would do division first. Then I have addition and subtraction. It's a tie. I go from left to right. And then my final answer is going to be 12. I go through and I do the next one next. And so my first step is to substitute for h what I'm putting in for h. Then I have multiplication and division. Those are tied. I go from left to right. Then I get the one step, and that should be my answer. Last but not least, I substitute when the variable is next to the numerical coefficient. That means I'm multiplying. So this should be 5 times 3. When I write a number next to another number in parentheses, that means it's multiplying. And that should be that third one. Then, neat. Write the square root for each perfect square, or write the cube, or write the cube root for each perfect cube. Make sure you're reading all the directions. I had a few students that didn't see the or there, and so they were not paying attention to the index, which is that little 2 or the little 3. And so it's asking what number times itself equals 81. The cubed root of 64 is asking what number times itself 3 times is equal to 64. Square root of 49 is 7. The cubed root of 1,000 is 10. Okay? Now, I can guess and check if I don't recognize some of these. So let's say it's the cubed root of 343. I can guess, and I'll say 6, and I'll do 6 times 6 is 36. And then I'll do 36 times 6, and I'll see that it's wrong. And I'll see if it's wrong. I'll see that it's wrong, and I'll see that it's too low for when it's wrong. And so then I'll guess higher, and I'll try that out until I get the right answer. Okay? So if I'm solving these, I want to use kind of a guess and check mentality. For these, the other thing I want to be looking for is where they estimate the nearest cubed root to the nearest tenth. So going over that would be a good thing to study.